In a realm where nature governs with an iron grip and water is a relentless, destructive force, humanity has chosen to accept the impossible challenge. We aren't just talking about building on solid ground. We are talking about diving into the great unknown, where the pressure is enough to turn bone to dust and the darkness is absolute. Imagine the weight of millions of tons of salt water, a hydrostatic power capable of crushing steel submarines like discarded tin cans. In this aquatic purgatory, engineers are plotting to carve a safe passage for people and commerce, a head-on collision with the laws of physics. Long before the first stone is laid, the story begins with seismic survey ships. They fire acoustic pulses deep into the ocean floor, mapping the secrets hidden beneath the silt. Knowing whether you're dealing with solid granite or treacherous clay is the razor's edge between triumph and total catastrophe. Every core sample pulled from the depths tells a geological story, millions of years in the making. Scientists pore over porosity and permeability data because a single miscalculation means the sea will breach the tunnel with explosive, unstoppable force, swallowing the entire project in heartbeats. The primary adversary is pressure. At a depth of just 50 meters, the water exerts a force of 5 kilograms on every square centimeter. The structure must be forged to withstand this crushing burden forever, resisting salt corrosion, seismic shifts, and the constant grinding of tectonic plates. In closed-door boardrooms, a war of intellect rages between architects and structural experts. The question isn't just how to build it, but how to breathe life into it, ensuring ventilation, preventing fire, and making a submerged concrete tube habitable for a century. Entry and exit points are chosen with surgical precision. A tunnel cannot dive at a jagged angle. It must descend with a grace that allows heavy freight trains and massive trucks to climb and descend without blowing their engines. This means digging approaches that stretch for miles before they even hit the shoreline. There are two ways to conquer the floor, either burrowing beneath the seabed with titanic machines or building the tunnel on land as massive segments, then sinking and connecting them like a gargantuan puzzle. Both paths are paved with terrifying risks. Nature doesn't sit idly by. Fierce currents, sudden storms, and the rhythmic pull of the tides all conspire to halt progress. This is a war of attrition against the elements. The cost is astronomical, exceeding the budgets of entire nations, billions of dollars, thousands of workers, and millions of tons of raw material. It is a high-stakes gamble on the future, requiring a level of political and engineering audacity that is truly unparalleled. Accuracy isn't measured in feet, but in millimeters. A slight deviation in the digging angle means the two ends of the tunnel will never meet in the middle, an engineering nightmare that would cost millions to rectify. GPS. Satellites and precision lasers are the guiding stars of this journey. A human army prepares for the miracle. Workers from every corner of the globe, professional divers, mechanical engineers, and explosives experts, all moving as gears in one massive machine. Their lives depend on the perfection of the plan. The naval invasion begins with a fleet of specialized vessels, massive dredgers, transport barges, and floating drill rigs. The calm surface of the sea transforms into an industrial hive, buzzing 24 hours a day. Beneath the waves, robots and divers clear the path, removing loose rock and ancient shipwrecks to ensure a stable foundation. It is a meticulous cleanup in a hostile environment where visibility is zero and danger lurks in every shadow. Now, the real work begins. The time for theory is over. The era of steel, concrete, and sweat has arrived. In the excavation phase, we don't use shovels. We use mechanical monsters that devour thousands of cubic meters of seafloor mud daily to carve a precise trench, the cradle where the tunnel will rest. Every scoop is weighed, and the debris is disposed of in environmentally protected zones to avoid choking marine life. It is a delicate balance between massive construction and the preservation of a fragile ecosystem. The trench is carved with laser-guided accuracy. Too shallow, and the tunnel is exposed to the currents. Too deep, and the walls collapse. It is a sculpture in the mud under immense water pressure. Once the trench is ready, the tunnel segments can't just sit on the silt. Specialized ships lay a bed of graded gravel, leveled by remote-controlled equipment until it is as flat as a mirror. The tolerance for error is nearly zero. Any protrusion or dip would cause the massive concrete structure to crack under its own weight. This underwater leveling rivals the precision of a Swiss watch. On the shore, a launch box is excavated a massive pit, the depth of a 10-story building, reinforced with thick concrete walls to hold back the water-saturated earth. Thousands of cubic meters of reinforced concrete are poured, chemically cooled to prevent cracking as it cures. The heat from the chemical reaction in these massive blocks is enough to boil water. A skeletal cage of interlocking steel bars, each as thick as a man's arm, forms the backbone of the retaining walls, designed to withstand the sheer force of the soil and groundwater, trying to crush the pit. Standing at the bottom of this pit is a humbling experience, surrounded by towering walls, holding back an entire ocean. This is where the boring machines are assembled, or where the first tunnel segments begin their journey. For immersed tunnels, a massive dry dock is built. Here, in the open air, concrete segments the size of small aircraft carriers are cast. The secret lies at the edges, where massive rubber gaskets, called GINA seals, are fitted. This specialized rubber is the only line of defense against the sea when the segments are joined underwater. The first moment of truth arrives when the dry dock is flooded. These monolithic concrete blocks rise and float, thanks to the principle of Archimedes. It is an engineering miracle to see a 50,000-ton rock float like a feather. Then, the towing begins. Powerful tugboats pull the floating segment at a snail's pace toward its destination. The operation requires perfectly calm seas. Any sudden surge could snap the tow cables and cause a maritime disaster. Guided by GPS and lasers, the segment must reach its position over the trench with centimeter-level accuracy. Sinking operations often happen at night to avoid thermal expansion from the sun. Under blinding floodlights, water is pumped into ballast tanks inside the segment, causing it to descend slowly into the dark abyss. It is a majestic sight, a building-sized block of concrete sinking silently toward the seafloor. Engineers control the descent using massive hydraulic jacks mounted on temporary towers. When the segment nears its predecessor, it is pulled in hydraulically until the rubber seals touch. The water between them is pumped out, and the external pressure of the ocean itself slams the two pieces together with incredible force, creating a watertight seal. Once the position is confirmed, a mixture of sand and water is injected under the tunnel base to fill any voids, a process called underfilling. This ensures the tunnel is fully supported and won't bend. Then, engineers open the bulkhead to step into the newly submerged segment. The only sound is the echo of their footsteps and dripping water. The air is cold and damp, and the feeling of walking beneath millions of tons of water is indescribable. To protect the tunnel from ship anchors or scouring currents, it is buried under layers of heavy rock, disappearing back into the seabed as if humanity had never passed through. But what if the sea is too deep or the currents too strong? That is when the mechanical titan, the TBM, or tunnel boring machine, takes the stage. In massive factories, the cutting head is assembled a steel disc 50 feet in diameter, studded with tungsten and carbide teeth, designed to grind through the hardest granite like it was sugar. The components, weighing thousands of tons, are lowered into the launch pit and assembled piece by piece, a logistical feat akin to building a ship inside a bottle. The machine moves on dozens of powerful hydraulic pistons that push against the concrete rings installed behind it, driving the cutting head forward with tens of thousands of tons of crushing force. The greatest challenge is mixed soil. Transitioning from hard rock to soft clay requires an immediate adjustment of the face pressure. If the balance fails, the ground can collapse, flooding the tunnel with mud and water. Inside the belly of the beast, pilots sit in air-conditioned control rooms, monitoring torque, rotation speed, and soil quality. They are flying a blind factory underground, relying entirely on digital data. The pulverized rock, known as muck, falls onto long conveyor belts, stretching miles back. This debris must be removed constantly. Any halt in the transport system stops the digging immediately. In water-saturated soil, a special fluid called bentonite is pumped to the digging face. This fluid forms an impermeable layer that keeps groundwater out and stabilizes the rock wall. When the cutting teeth wear down, workers must enter a hyperbaric chamber behind the head, working in conditions similar to deep-sea diving. breathing a special gas mix to avoid the deadly bends. With every meter the machine advances, the tunnel grows behind it, a concrete tube stretching into the darkness, stubbornly carving a path toward the other side of the ocean. Here, we witness the birth of the tunnel's superstructure. It isn't skyscrapers or columns, but interlocking concrete rings that form the spine of this vital artery. Each ring is a shield against the ocean's wrath. A massive robotic arm, called an erector, picks up a curved concrete segment, weighing several tons, and rotates it with millimeter precision to lock it into place. Once the segment is set, workers rush to secure it with massive steel bolts, torqued to exact specifications, to ensure the ring can distribute external pressure evenly. Between the concrete ring and the excavated rock, a small gap is immediately injected with fast-setting cement grout. This locks the ring in place and seals any leaks. Sensors embedded in the concrete show how the loads are distributed. Once the grout hardens, the ring becomes part of the earth itself, capable of withstanding hundreds of bars of pressure without flinching. Supply logistics are a miracle in their own right. Special trains run inside the partially completed tunnel, transporting segments, materials, and workers to the front line in a never-ending cycle. Air is gold here. Massive yellow ventilation tubes pump fresh air from the surface to the work zone miles away, sucking out dust, heat, and harmful gases. A laser guidance system constantly monitors the TBMZ path. Any deviation of a few centimeters is corrected by adjusting the hydraulic pressure on one side of the machine. Suddenly, the machine might hit a high-pressure water pocket. Sirens wail as water gushes from rock fissures. This is where the engineer's mettle is tested. Emergency chemical injection systems are activated to seal the cracks instantly. In extreme cases, the ground ahead is frozen using liquid nitrogen, turning saturated mud into solid ice so the machine can pass safely. Every few hundred meters, cross passages are dug to connect the two main tunnels, vital for emergency escapes and maintenance. These are carved manually or with smaller machines with high precision. The cross passage walls are reinforced with shotcrete, concrete sprayed at high pressure to bond with the rock and harden instantly. In seismic zones, the tunnel cannot be perfectly rigid. Flexible joints are installed to allow segments to move during an earthquake, absorbing energy rather than shattering. Reaching the midpoint beneath the ocean is a psychological milestone. Workers scrawl the distance on the walls. There is no turning back now. The only way is forward, toward the light at the end of the tunnel. The breakthrough is the peak of the drama. On the other side, those waiting hear the sound of grinding rock approaching. The wall vibrates, dust flies, and everyone holds their breath. With a thunderous roar, the final wall collapses, and the metallic cutting head emerges from the dust like a legendary beast rising from the earth. Cheers erupt. The rock and water have been conquered. After its mission is complete, the massive TBM is dismantled. Often, the outer shell is left buried as part of the tunnel, while the motors and electronics are salvaged. Now we have a dark, grimy skeleton. Cleaning crews wash the concrete walls with high-pressure water to remove oil and dust. The entire tunnel is scanned with 3D lasers to ensure there are no unforeseen deformations. This digital model becomes the reference for maintenance for the tunnel's entire life. Despite the precision of the build, a secondary insulation layer is added high-durability plastic membranes to prevent any future moisture from reaching electrical cables or equipment. The circular floor of the tunnel isn't fit for driving, so invert concrete is poured to create a flat surface. Beneath this floor run drainage pipes and high-voltage cables. At the tunnel's lowest point, a massive pumping station is installed. Any seepage or firefighting water must be pumped up and out to the sea, or the tunnel would slowly drown. In immersed tunnels, ballast tanks are filled with heavy concrete to ensure the tunnel never floats, even if it were completely emptied of air. Weight is the only guarantee of stability on the ocean floor. On either side, elevated emergency walkways are built. These concrete platforms house cable ducts beneath them and provide a safe path for evacuation. Fire in a subsea tunnel is the ultimate nightmare. The ceiling is coated with specialized heat-resistant materials that prevent the concrete from exploding under extreme temperatures. To dampen the roar of passing trains or cars, acoustic panels line the walls. Sound comfort isn't a luxury. It's a necessity for communication during an emergency. The rail laying phase begins, using long welded rails to minimize vibration. traction. The tracks are mounted on rubber pads to absorb shocks and protect the concrete structure. On the ceiling, a complex electrical grid is hung to power the trains, carrying thousands of volts while being shielded from the tunnel's natural humidity. If it's a road tunnel, specialized asphalt is laid material that doesn't produce toxic smoke if tires catch fire and has high friction to prevent skidding in the damp air. Lighting is a science here. Thousands of LED units are installed. Near the entrances, the light is intense to match the sun, fading gradually so drivers aren't momentarily blinded. Jet fans, hanging from the ceiling like jet engines, are the tunnel's lungs. They push out polluted air and control smoke movement during a fire. Every meter is monitored. Cameras detect accidents automatically, and sensors measure carbon monoxide and heat. The smart system can close the tunnel and trigger alarms without human intervention. All this data flows into the Central Control Center, an operations room that looks like NASA. Operators monitor the tunnel's pulse 24 hours a day. Heavy steel fire doors undergo rigorous testing. They must be easy enough for a child to open, but strong enough to block smoke and flames for at least 2 hours. Phosphorescent signs are the language of survival in the dark, placed low, so they remain visible even if the upper part of the tunnel fills with thick smoke. The tunnel cannot be a dead zone. Special cables are run to broadcast radio and cellular signals, ensuring passengers stay connected to the outside world and rescue teams to the control room. At the entrances, engineers focus on aesthetics architectural cladding that reflects the country's identity and eases the dread of entering a black hole. The smoke test is the final dress rehearsal. Non-toxic smoke fills the tunnel and fans run at full power. The smoke must be cleared in minutes for the ventilation system to be certified. In some modern tunnels, water mist systems are tested massive nozzles that release a high-pressure spray to cool fires and protect the structure. Hundreds of volunteers participate in mock evacuations, measuring movement speed and the clarity of voice instructions. Massive electrical substations dedicated solely to the tunnel are brought online. The tunnel consumes as much power as a small city and must have multiple backup sources to ensure the lights never go out. Before the grand opening, a final cleaning fleet enters trucks with massive brushes, wash the walls and floors until the tunnel shines. The engineers who spent years of their lives on this project proudly explain the details to officials. Every bolt, every cable, and every piece of concrete has a story of struggle. As the sun rises on opening day, a calm settles over the structure. What was once just ink on paper is now a monolithic reality of steel and concrete, ready to change the geography of the region. With the cutting of the ribbon, construction ends and operation begins. But the true story isn't the ceremony, it's the triumph of human will. The first vehicle to cross is a historic moment, crossing a boundary that was once impossible, turning hours of travel into minutes. Passengers look out the windows, perhaps seeing only concrete walls, but they feel the magnitude of the achievement. They are traveling on the ocean floor, in total safety, thanks to the genius of engineering. Outside, beneath the waves, life has returned to normal. Fish swim over the buried tunnel, unaware of the bustling movement within its bowels. The alien structure has merged peacefully with nature. At night, car lights twinkle like a river of gold flowing underground. The tunnel never sleeps. It is a living artery, supporting the economy and easing the lives of millions. But the work never ends. Every night, maintenance crews, the unsung heroes, ensure this giant stays safe, checking for cracks and replacing bulbs. The success of such a project whets the appetite for even bolder ventures. Tunnels connecting continents, floating tunnels, and ultra-high-speed rail links. The boundaries of the possible expand every day. From mud and water to steel and light, a journey that began with a crazy idea has become a tangible reality. It is a permanent reminder of what humans can achieve when they unite. Beneath these blue waves lies living proof of human courage. We are no longer content just living on the surface. We have mastered the depths. We have redrawn the map, not with ink, but with concrete. This tunnel is more than a road. It is a bridge to the future. Even the smallest detail, like a single bolt, plays its part in the grand design. Preventive maintenance is the secret that prevents disaster and extends the tunnel's life for decades. The air quality inside is maintained at levels that sometimes rival mountain air, thanks to massive filters. Safety barriers are designed to absorb impacts, And the heartbeat of the tunnel, the pumps, ensures it never drowns. Sacrificial anodes of zinc corrode so the steel reinforcement doesn't have to, sacrificing themselves to protect the core from salt. Emergency phones, every 100 meters, offer a lifeline. Expansion joints allow the tunnel to breathe with the temperature. The old-fashioned acoustic test tapping walls with hammers still proves that human experience is irreplaceable. The electronic eyes must never blink. In the relentless gloom of the subterranean world, dust and exhaust fumes act like a veil, threatening to blind the lenses that watch over the passage. To counter this, a rhythmic cycle of cleaning ensures the control center maintains a crystal-clear view of the pulse below. Should the city's power grid falter, massive diesel generators roar to life within seconds, sustaining the lifeblood of the tunnel lighting, ventilation, and pumps. Here, total darkness is not an option. It is a catastrophe held at bay. Meanwhile, smart traffic management systems act as a silent conductor, adjusting speed limits at the first sign of a bottleneck. By slowing the flow before a jam can form, they prevent a total standstill, keeping the current moving through the narrow concrete artery. At the gates, thermal cameras act as sentinels, scanning every truck for the invisible heat of a failing engine or glowing brakes. Any vehicle running too hot is pulled aside immediately, a preemptive strike against the nightmare of an underground fire. Above, the white-tiled ceilings are more than an aesthetic choice. They are designed to bounce light and conserve energy. Specialized washing trucks regularly restore their luster, ensuring the illumination remains efficient and the drivers feel less of the crushing weight of the earth above. For the ultimate protection of life, safe refuge rooms stand ready, pressurized, air-conditioned sanctuaries designed to keep smoke out. These oases can shelter dozens for hours, equipped with water, first aid, and a direct line to the surface, serving as a fortress of safety in the heart of a disaster. Working in tandem with these defenses is an innovative water mist system. It fights fire with the elegance of physics, absorbing intense heat and scrubbing the air of smoke without drowning the scene in water. To ensure no one is left in the dark, the public address system is engineered to pierce through the deafening roar of engines. Directional speakers deliver razor-sharp instructions, guiding every driver toward the nearest exit with calm authority. Above the tunnel, the artificial islands rising from the water are not resorts, they are the project's lungs. Their massive ventilation towers inhale the crisp ocean air and pump it deep below, while simultaneously exhaling the toxic exhaust back into the sky. The SCADA system serves as the electronic brain, weaving thousands of sensors and devices into a single, sentient network. It gathers data in real time, analyzing and executing autonomous decisions to adjust airflow and lighting as conditions shift. Deep within the walls, the freezing pipes used during the initial construction remain buried, silent witnesses to the war engineers waged to stabilize the liquid soil. Decades later, the battle continues through chemistry. Concrete samples are regularly tested for carbonation, ensuring the alkalinity still shields the steel reinforcement from the slow rot of rust, guaranteeing a century of structural integrity. Seismic sensors detect tremors far below the threshold of human perception, providing data that allows engineers to refine safety protocols and understand the tunnel's shifting behavior. Even the smallest hairline fracture is met with high-pressure injections of specialized resins, which penetrate the deepest pores and crystallize, becoming even stronger than the original concrete. This evolution is constant, replacing aging lights with modern LED generation slashes energy consumption and reduces ambient heat, easing the burden on the massive cooling and ventilation plants. In the cramped, dark veins of the drainage system, small robots crawl where humans cannot reach, inspecting for blockages or corrosion, and beaming high-definition images back to the maintenance crews. Repaving the road surface is a high-stakes logistical ballet, performed in the dead of night within a tight window of a few hours. The old layer is stripped and the new one laid with surgical precision to ensure the road height never compromises overhead clearance. To protect the delicate machinery above, laser height detectors act as a final warning, stopping oversized trucks before they can strike the multi-million-dollar ventilation fans hanging from the ceiling. Readiness is a religion here. Firefighters conduct grueling drills within the tunnel, knowing that an underground blaze is a different beast. The heat is trapped, the smoke is suffocating, and access is a nightmare. In the rail segments, emergency slides are tested to ensure that hundreds of passengers can be evacuated from a stalled train in total darkness without the chaos of a stampede. When an incident does occur, variable lane signals instantly close off the affected area, creating a protective buffer for a disabled vehicle and carving a clear path for rescue teams to descend. The control center even has the power to override the airwaves, cutting into car radios with a clear, urgent command. Attention, accident ahead. It is a voice from the depths that can save a life. Even drones have joined the ranks, hovering near the ceiling to inspect bolts and high-altitude equipment without the need for scaffolding or traffic halts. At critical junctions, impact absorbers filled with water or sand stand ready to sacrifice themselves, absorbing the violent energy of a crash to protect drivers from the unforgiving concrete corners. Reflective road markers act as grounded stars, guiding drivers through the long transit. Regular cleaning ensures they flare to life the moment a headlight hits them, defining the path with absolute clarity. In the side channels, thousands of miles of cabling are meticulously organized to prevent EMI, or electromagnetic interference, making it easier to trace complex electrical faults. Below the road, high-pressure water jets keep the drainage pipes clear of sediment, ensuring that every stray drop of water is whisked away before it can pool. After decades of service, the data confirms a triumph. The structure has stabilized, the concrete has only grown harder with time, and the tunnel has anchored itself as a permanent fixture of the local geology. As the sun sets, the tunnel stands as a monumental gateway between two worlds. It is far more than an engineering feat. It is a lifeline for families, a conduit for global trade, and a path for ambulances racing against time. Every journey through these depths is a quiet success story, authored by the thousands of workers and engineers who dared to build it. Behind every ton of concrete lies a human mind that envisioned it, and a human hand that labored for it. These are the unsung heroes of our civilization. If we could turn back the clock, we would see the millions of man-hours and the literal tons of sweat that went into this achievement. All those challenges have faded into history, leaving behind a path through the darkness of the ocean, a testament to the human spirit.